Hopefully, you recall basic indexing and slicing from this lecture. If not, please go back and refresh your understanding of the concept. With NumPy arrays, all the same functionality you know and love from lists is still there. These operations all work whether you're using Python lists or NumPy arrays.
Okay, and I could prove that it's 2 by 7 by doing a.shape. That's just a reminder. So what if we wanted to get a specific element? Well, to do that, we can use this notation of row, comma, column. So this is the row index, this is the column index. So I could just do something just like let's say I wanted to get this 13 right here. Well, that would be in the second row, but because we start Python indexing at 0, be the first row, and then the 0, 1, 2, 3, 4, 5, fifth column. So yeah, that gives us the 13 as you see down here. And one thing that's kind of cool is you can also use the negative notation similar to lists. So I could also say the negative second element would be 13 as well, because this would be -1 and then -2. So there's a couple different ways to do this, but we'll stick with the first one. Okay, let's say we wanted to get a specific, I can't spell, row. That's pretty straightforward as well. So in this case, if we wanted the first row, we would do 0, and then because we want all columns, we use the basic slice syntax similar to lists. I can just do a single column, and that will get me everything in the row. That's nice. What if we want a specific column? Well, if you know how to do rows, you probably know how to do columns. Let's say we wanted this row, right, or this column right here, 3 and 10. That would be all the rows, and then the 0, 1, 2 column. That gives me the 3, 10. And from here, we can do even some more like tricky stuff. So I'm going to just say getting a little more fancy. We have the start index. This is just a reminder, start index, end index, and then finally the step size. So if I wanted to, let's say, get between the numbers 2 and 6, every other element, so 2, 4, and 6, well, to specify that, I would do, well, I want the first row, and then I want to start at the first element, 2. I actually screwed that up, it should be 1. So I start at the 2, then I want to end here at the 6, which is the, it's exclusive, so that would be, I want to actually go to the 6th element, and then I want to step by 2 because I wanted 2, 4, 6, so I do 1, 6, 2, and that gives me 2, 4, 6. And I can also use the negative here and do like -2. What happened there? Oh shoot, that was going backwards. I didn't want to change it there. I wanted to change the 6 to be -2. Okay, it's exclusive, so I want this to actually be -1. A little bit more of a fancy way to do that. Okay, so that's how you access elements. And then if we wanted to change something, it's pretty straightforward too. Let's say I wanted to change that 13 that I originally accessed. Well, I can just do like 20. If I print out A now, that original element that was 13 is now 20. And you can do the same thing for series of numbers. So like for an entire column, let's say we wanted to replace this 310 column, I would do something like A colon 2 equals, let's say I wanted it to be all 5s. I could start like this. And as you see, it's all 5s, 5, 5. And then if I wanted it to be 2 different numbers, you just kind of specify the same shape as what you've subsequenced. So it'd be like 1, 2. So now you see that we have a 1, 2 in that position. Really quickly, let's just show a 3D example. If I had a 3D, so we'll say B equals NumPy array of all of this. And if I print B, so if we want to get a specific element here, the recommendation I have is work outside in. So work outside in. So let's say I wanted this 4 right here. Well, the farthest outside would be which one of these do I want? And I want the first set, so I want this area right here. So if I wanted that, I would do B 0, and then now that I'm in here, I want the second row. So I want the 3, 4, so that would be 1. And now that I'm within this, I want the first, or the second, the second element, but the first index, like that. So that gives me the 4. And you can do similar type stuff with like the colons in here. So each one of these dimensions that you're indexing, you can be all fancy with how you access elements. So I can do something like this and, get 3, 4, 7, 8. You can kind of play around with this and see how changing different things changes what you get. And if you wanted to replace in this case, basically you just have to create a subsequence that's the same dimension. So if I did B1, this, it gives me 3, 4, 7, 8. Let's say I wanted to change that to 9, 9, 8, 8. As long as it's the same dimension, it's going to work. So 9, 9, 8, 8. If I try to do something like 9, 9, 9, 8, 8, it's going to have an error. All right, so that's the basics of index. So to start off, let's initialize an all zeros matrix. And to do that, there's a nice built-in function called np.zeros. And we can first, I guess actually all we really need to do is specify a shape. So I did like np0 is 5. It's going to just give me a vector of 5, length 5. But I also can pass in a more complex shape. So if I wanted it to be like a 2 by 2 or 2 by 3, let's say, as you see there, I could do 3-dimensional, 2 by 3 by 3. Could even do 4-dimensional if I wanted to, 2 by 3 by 3 by 2. It gets pretty crazy, but yeah, you can do all sorts of zeros with that. Next, let's do an all ones matrix, pretty similar to the last one, np.ones of, let's say, 4 by 2 by 2. And there you go. And you can also specify the data type here. So if you wanted like all ones but in 32, you can go ahead and do that. So all ones, all zeros. However, you might want to initialize a matrix that's not ones or zeros, any other number. So for that, you can do np.full. And this one takes in 2 parameters. So the first is the shape, so 2 by 2. And then the next is the value. So if I wanted all 99s, then it's a 2 by 2 with 99. Another useful, and you can, that has a data type too. So if I wanted that to be float 32, there you go.